world of constant noise, we find clarity in chaos.
The Earth's surface is not consistent. It is constantly being transformed by.
The Earth is made up of three main layers: the crust, mantle, and core. The crust is the outermost layer on which we live. The crust, along with the upper part of the mantle, forms the lithosphere, which is broken into different tectonic plates. The movement of tectonic plates is caused by convection currents in the mantle, where heat from the Earth's core causes molten material to rise. Plate tectonics is an important theory, given by W.J. Morgan, that explains this movement of the Earth's crust. Plate tectonics is an important theory, given by W.J. Morgan, that explains this movement of the Earth's crust. When an oceanic plate collides with a continental plate, the oceanic plate sinks, leading to volcanic activity and earthquakes. At a divergent boundary, plates move away from each other, and magma rises from below to form new crust, creating features like mid-ocean ridges.
Finally, at a transform boundary, plates slide past each other without creating or destroying crust, primarily causing earthquakes.
Most earthquakes and volcanoes occur along plate boundaries, especially around the Pacific Ocean, an area known as the Ring of Fire.
In India, a unique example of geological activity is the mud volcano at Baratang Island in the Andaman and Nicobar Islands, where mud bubbles out.
Weathering and erosion work together to wear down these landscapes. Physical weathering breaks rocks through temperature changes, frost, or wind. Chemical weathering occurs when minerals in rocks change because of reactions with water, air, or acids, leading to new substances. Biological weathering is caused by plants, animals, or microorganisms, like when plant roots grow into cracks and split rocks apart.
While weathering breaks down rocks, erosion is the process by which soil and rocks are worn away and carried from one place to another.
To combat erosion, ancient practices like the Zabo system in Nagaland use earthen bunds
where hard rocks resist erosion while softer rocks below are worn away. Rivers flow over a vertical drop to create dramatic waterfalls.
In the middle course, the river starts to meander. It erodes the outer banks of bends and deposits sediment on the inner banks, creating large loops. In the lower course, the river slows and deposits large amounts of sediment, forming a fan-shaped delta.
Sea waves act as another agent of gradation, constantly reshaping the coastal zone and creating landforms like beaches through the deposition of sediments.
Coastal erosion wears away the land, creating steep rock faces known as sea cliffs when waves undercut the base of the coast. Continuous wave action can erode weak parts of rock to form caves, which break through to become arches and eventually collapse to leave isolated pillars called stacks. Glaciers act as frozen rivers, scraping and carrying huge amounts of material as they slowly move, carving wide, deep, U-shaped valleys. At the head of a glacier, they form bowl-shaped depressions called cirques, while the sharp ridges between these valleys are known as aretes. When these deep glacial valleys are eventually flooded by the sea, they create stunning, steep-sided inlets known as fjords. As glaciers melt, they leave behind the rocks, soil, and debris they carried. These deposited landforms are called moraines.
Wind also deposits sand into hills or ridges called dunes. Barchan dunes are crescent-shaped.
Where winds come from multiple different directions, the sand piles up to create complex, multi-armed structures known as star dunes. Underground water creates unique karst topography by chemically weathering soluble rocks like limestone, creating massive cave systems. Inside these caves, dripping mineral-rich water forms stalactites hanging from the ceiling and stalagmites rising from the floor. When an underground cavity becomes too large to support the earth above it, the ground collapses, forming a dangerous depression known as a sinkhole.
These systems can also host entire underground rivers, providing sources of fresh water but remaining largely hidden from the surface.
These landforms are dynamic and sometimes dangerous. Heavy rainfall and steep slopes can cause the earth to give way. In mountainous regions, a sudden instability in the snowpack, often triggered by heavy snowfall or a rise in temperature, causes deadly avalanches. Rapid melting can overfill glacial lakes. If the natural moraine dams break, it releases sudden, destructive. In arid regions, strong winds lifting loose, dry soil can create massive, suffocating dust storms, stripping the land of its topsoil. The Earth's surface is a delicate balance. The same rivers that provide fertile soil for agriculture can also bring devastating floods. Human life is deeply connected to these landforms. They influence our settlements, trade, resources, and very survival. Understanding the dynamic forces that shape the Earth's surface helps us appreciate nature's power and prepare wisely for the future. Human life is deeply connected to these landforms. They influence our settlements, trade, resources, and very survival.
A continuous, powerful transformation, echoing through geological time. In the silence of the flow, education is reimagined. Seek the wisdom of the infinite. Subscribe, like, share, join the flow. An Aranya Panda film.